Hi guys, welcome back to our channel. This is Analyst One. So the topic of today's discussion will be risk management. So for today's video, I have picked one of my projects that in risk management that I did for one of my firms where I have previously worked with. So this project involves volatility modeling. So as you can see in the screen, there is historical simulation, JP Morgan risk metrics, GARCH 1.1, eGARCH, and all those other branches of GARCH models. So how I have planned to do this series of videos, I thought of making a series of miniature videos where this whole project will be distributed in parts. So instead of making a elaborate and longer video, I thought of picking up a few small sections of this project and then make a video out of it, so that later on if any person who have a particular topic to deal with, who wants a elaborate discussion on a particular part of that project, he could directly refer to that miniature video and get his or her doubts cleared. So okay, so this project is in volatility modeling, as I have already said. So as part of this project, I did this modeling on Indian bond market. So for that, I have picked the data which is total return bond index. So sorry for guys, the screen just got stuck a bit. We'll wait for it. Yeah. So yeah. So yeah, as you can see, this is the data that I have collected. It's basically total return bond index composite of the Indian bond market. So I've collected the data from 14th of October 2001 till I guess 26th of September 2014. So yeah, it's a whole project, that's why you might be guessing that why I have taken data till 2014. I have made this project long time back, 5-6 years back. So yeah, so that's the thing. So these are my data, like all those data regarding the bond index composite, and this is how I calculate the returns. Basically I've taken natural log in calculating the returns, and the residuals of EVs and all those stuff that I will discuss later on in some later videos. So basically what I would like to show you in this video, the various tabs. This is the output Excel file that you will finally generate after you complete the project. So I'll just discuss the various tabs in this video that will be generated after you are done with the modeling part of the project. So yeah, the first tab, that is the equations, I have kept it in this fashion. So there are confidence intervals that I have taken from 95% till 99.5, and the intervals is of 2.5%. I have incremented them in this fashion. 2.5% incrementation, 95%, 97.5, 99. Okay, so then comes the historical simulation and all those equations, other volatility modeling uh, parameters, or you can say volatility modeling methods. So these things, how this formula I have developed or how I worked on this, that I will go in detail in the next video. So this is basically a summary of what is done inside, then the models, then the dependent variable over here, variance, log var, standard deviation to the power 1.32345 and all those things, and these are basically the equations. The simplest one of them is at the top, which is 0.94 multiplied by variance t minus 1 plus 0.06 r square t minus 1. This you guys might have read in your MBA books or CFA, or if you guys are doing FRM and all those stuff, you might have gone through this formula. Okay. So yeah, so the next tab is of the descriptive statistics of the data, mean, standard error, median, mode, standard deviation, and all those stuff. You can easily make this thing directly from the Excel, the data analysis tool. You can use it. Then the next tab is of var calculations. I'll go to a great detail in my next video dealing with this. So as you can see, I have made 4 columns for each of the methods of volatility modeling, from 95% confidence interval to 99.5. So this is JP Morgan, then Garch 11, Garch 11 students T, ARD Garch, E Garch, Parch, Parch student T, M Garch, and so on and so forth. So the next tab is regarding backtesting. It's very important that when you create a model, you obviously backtest the model, that whether your model is good enough in all the scenarios. So that's why you always have to do backtesting. So this is the summary of backtesting, which model worked well, which didn't. So this is the thing. Then LR test, you can also do this for testing your model, LR test. And after that, there are a series of charts that I have prepared that graphically represent what the output of your model is showing. So the first chart is the master chart normal. Those chart will be bit of heavy because they deal with a large number of data. So this is the master chart. So where I have shown all the models. As you can see, returns, historical simulation, JP Morgan, Garch, eGarch, Parch, iGarch, and mGarch. You might be seeing that except the returns, every model is starting from 14th of October 2004. So why there is a lag? I mean, why there isn't any graphs regarding other models from 14th of October? Sorry guys, from 14th of October 2001 till 14th of October 2004. Actually, this period, as you can see, this period I have taken to model my data, and then I have forecasted my model volatility in the rest set of data, right? So that I can compare my forecasted volatility with the actual one for the purpose of backtesting, or to see how far my model is good enough to be applied. Okay, so the next chart is master chart students T. So just wait a while. I mean, these charts are heavy, so they might take a bit to show up. Yeah, this is students T. Then you have stuff like Garch 1-1 versus JP Morgan, then E-Garch versus historical. So in this fashion I have shown all the charts, and there is also one segment of QQ plot. Wait a while, the QQ plot will show up here. So there you can see the QQ plot, quantile plot basically, and this is the data where from this chart is getting created. I'll discuss, don't worry, I'll discuss all those nitty-gritties of this project in great detail in later videos. So then QQ plot Garch 1-1, this is the quantile plot for the same. Then QQ plot E Garch and the QQ plot for the same. Okay, so I think that will be all for today's video, guys. I have just given you an overview regarding how an volatility how a volatility modeling output file looks like. So this is that, and later on I'll go ahead and in discussing each of the procedures or methods, as you can say, how I have built up this model, and how I have collected the data, crunched the data, scaled the data in creating this whole project. So more things coming in later videos of mine, so stay tuned. And that's all from my side, guys. And if you like this video, do share, subscribe, and hit the like button, and do subscribe to our channel, Career at Market Value. That's all, guys. Thanks.